Today's topic, we're going to be talking about acid rain, conjugate acid-base pairs, buffers, and buffer problems. Acid rain is rain that has a pH of less than 5.6 because it naturally has a pH lower than 7 because of the carbon dioxide in the atmosphere. But other sources or components of acid rain is sulfuric acid, nitric acid, and HCl. Major sources of acid rain comes from burning of coal, fossil fuels, industry, and of course, Mother Nature through lightning and volcanoes. Now, as you can see in this little diagram, the different gases go up into the atmosphere, and when it combines with the water, then it rains down and it is more acidic if these gases are in abundant supply. The acids that are produced is just like the reactions that we saw in our monster acid-base lab. CO2 in water gives you carbonic acid, SO2 and H2O gives you sulfurous, then we have sulfuric, nitrous, and nitric acid. Now, as far as the acid rain in the United States, winds normally come from the south and the west, so that acid rain, that cloud cover, and then when it starts to rain, or the highest acid rain content would be in the northeastern part of the U.S. So if you take a look at this little diagram, as you can see, the red has the higher pH, well, the higher acid rain content, which really means the lower pH, and so these areas are affected the most. Now, effects of acid rain. It affects plant life, brown spots on plants, animal life, lakes, lowers fish population, still life. So let's take a look at a couple diagrams. Brown spots on plants. Animal life, acid rain kills rivers. This river's dying. And of course, the fish population dies. And then on still life, statues and buildings, statues made up of marble, which is limestone, that reacts with the acid and produces carbon dioxide, water, and calcium sulfate. And as you'll notice in this diagram, here we have a statue maybe 30 or 40 years ago. Here it is today without much protection, and the acid rain is deteriorating it.